Hello guys, so in this video, we're going to find out how to find the tangential component of an acceleration. So we're given this formula, which is the tangential component of a position vector would be velocity times acceleration times speed. But to make this easier for ourselves, we're given a position vector r of t. When we see r prime of t, first derivative, r double prime of t, second derivative, divided by the first derivative and its magnitude. So that's what we're going to go ahead and compute right now. So first things first is we're going to find at a time, keep in mind we're given at a time of pi. But for now, we don't worry about this. For now, we are going to just follow this step by step. So the first step, find r prime of t and r double prime of t. So to do that, we perform calculus. We take differentiation. We take the first and second derivative of these functions. So r prime of t is equal to the first derivative of sine would be cosine of t. First derivative of cosine of t would be negative sine of t. The first derivative of t is equal to 1. Now, the next step is to find the second derivative. So we take the derivative of this function right here, because this first derivative gives us velocity, second derivative gives us acceleration. But for this formula, we can follow this formula. It's pretty easy to follow. So the first derivative of cosine is negative sine of t. First derivative of negative sine of t is negative cosine of t. First derivative of 1 is of any constant is 0. So now we have these two formulas. So now the next step is we're going to go ahead and find the magnitude of r prime of t. So the magnitude, so we take the square, so we square the terms, add them together, square root. So that's simply how we find magnitude. And in doing so, we get cosine of t squared plus negative sine of t squared plus 1 squared, all inside a square root. Now, the trick to this one is knowing that cosine squared x plus sine squared x is equal to 1. So we can essentially just substitute in 1 for where we see these two being added together, which is essentially what's going on here. So without further ado, this is equal to, these two being added together is equal to 1. And I would say get familiar with trig identities, because they come up a lot for these type of problems, for curvature, tangential acceleration, all that stuff. So 1, which is just these two, plus 1 squared is just 1. So this is actually equal to the square root of 2. So that's our magnitude of r prime. So now the next step is we're going to find the dot product. So we're going to find, because the formula tells us we have to find r prime dotted with r double prime. So that's the next step, is we're going to find the dot product, r prime and r double prime. And in parentheses, I'll put dot product so you don't accidentally compute a cross product. So for this, I'm just going to go ahead and write down what r prime is and r double prime. So r prime, cosine of t, negative sine of t, and 1. And 1. Dot product, or the r double prime of t, sorry, would be negative sine of t, negative cosine of t, and then 0. So now the next step is we're simply just going to dot these. So we're going to dot these. So r prime of t dotted with r double prime of t is equal to, I'll go ahead and continue down here. So we're doing dot product computation. So cosine of t times negative sine of t plus negative sine of t times negative cosine of t. Okay. I'll include it down here. Plus, so I'm doing the middle terms. Negative sine of t times negative cosine of t, and then 1 times 0 zeroes out. So when we simplify this, we have plus sine of t plus sine of t cosine of t, because these two minus signs are positive, minus, all I did was flip the order, sine of t cosine of t. So this minus this is actually equal to 0. So our r prime of t dotted with r double prime of t is actually equal to 0. So now what does that mean? So the next step is to plug into formula. So we have our r prime of t, r double prime of t is equal to 0 divided by the magnitude, which is, so we have the tangential component is equal to r prime of t dotted with r double prime of t divided with the magnitude of r prime of t. So in this term, it didn't even matter what the time was, because r prime dotted with r double prime is 0 over the magnitude of 2, which just means that we have no acceleration from the tangential component. So what does this really mean? It means that all the acceleration is coming from the normal acceleration, and there's no tangential acceleration. But the answer to all this is equal to 0. But the key is to just follow all the steps. So what do we do quickly in retrospect? So the first thing we did is we identified r prime of t and r double prime of t. The next step is we took the magnitude of r prime of t to get our denominator, our speed. And in this case, we got a magnitude of the square root of 2. Why? Because cosine x squared plus sine x squared, that trig identity, is equal to 1. And then so we substitute it in here. So 1 plus 1 is equal to the square root of 2. From here, we took the dot product of r prime of t and r double prime of t, and we noticed that negative sine, cosine, positive sine, cosine, which means they're alike terms, which means we can add them together. So plus sine t cosine t minus sine of t cosine t is equal to 0. And we got this, and then we plugged into the formula, 0 divided by negative, the square root of positive 2. And we get 0 as our final answer. Thank you for watching. I hope that was helpful. Hello guys. So in this video, we're going to be computing tangential acceleration, which is slightly different from normal acceleration. But anyways, so we're given this formula. Tangential acceleration would be equal to r prime of t dotted with r double prime of t divided by r prime of t magnitude. So velocity dotted with acceleration divided by speed, basically. So we're given a position vector right here, r of t is equal to this function, is equal to this vector at a time of t equals 1. So we're going to find the tangential acceleration at the time of t equals 1. So the first thing we're going to do is we're going to find r prime of t and r double prime of t. So we simply do that by taking the first and second derivative of this function r of t. So without further ado, r prime of t is equal to 3t squared plus 16t plus 200t cubed. That's r prime of t. Now r double prime of t is equal to 6t, 16, 600t squared. And all I did was just take the first derivative of the position vector r of t and take its second derivative. So now, the next step is we have to compute the dot product. So we're going to find r prime of t. Actually, first, we're going to go ahead and take the magnitude of r prime of t. So I'll put magnitude in parentheses. Over here, I'll put dot product so you don't accidentally take the cross product. Okay, so now we're asked to find the magnitude. So in doing so, the magnitude of r prime of t, not r double prime, of r prime of t, because magnitude of velocity is speed, so we're going to compute 3t squared plus 16t squared plus 200t cubed squared inside a square root. So we're going to go ahead and simplify this. So r prime of t magnitude is equal to 9t squared, 9t to the fourth, plus 16t squared would be 16 squared is 256. 256t squared plus 200t cubed. 200t cubed to the square would be plus, oh, that's a big number. 40,000. T to the 6th power. So that's our third term. So yeah, barely fit it on there, but it's on there. So we have, there's a t right there. So I'll make this a little bit cleaner. So this is equal to 9t to the 4th plus 256t squared plus 4,000 t to the 6th. So now the first thing we do is we can go ahead and factor out a t squared out of each term, which is what I'm going to do. So t squared is equal to 9t squared plus 256 plus factoring out t squared out of t to the 6, we would simply to get t to the 3rd. Plus t to the 4th power. And all this is within a square root. So now the next step is to split up the square. So we have, organizing this in descending order, we have 4,000 t to the 4th plus 9t squared plus 256 t squared inside a root. So this is equal to t dotted times 4,000 t to the fourth plus 9t squared plus 256. And this is our magnitude. So this is equal to all this. So I'm going to write it one more time. So this is our r prime of t. So this value. Now the next step in our formula is we have to compute r prime of t dotted with r double prime of t. So we're going to go ahead and do that on another sheet of paper. So we're going to find r prime of t dotted with r double prime of t. So we're taking the dot product. So in doing so, when we take the dot product of r prime of t of these two terms, which I'm going to go ahead and write down real quick. So three t squared, 16t, 200t cubed. R double prime of t is equal to 6t, 16, and 600 t squared. So now the next step is we're going to dot these two. So r prime of t dotted with r double prime of t is equal to 3t squared, 16t, 200 t cubed dotted with 6t, 16, don't confuse those, 600 t squared. And when we dot these, we'll multiply alike terms together. So 3t squared times 6t would give us 18t cubed plus 16t times 16 will give us 256t plus, I'll put parentheses so you don't confuse the t's with plus signs, 200t cubed times 600t squared would give us 120,000. T cubed times t squared is t to the fifth power. And this is our dot product. So now, the next step is we're going to go ahead and plug all this in. So this is our, we're going to go ahead and leave it like this. This is our r dotted with r prime dotted with r double prime. So now the next step is we're going to plug into formula. So we're going to go ahead and plug this into the formula. So the formula is tangential acceleration is equal to that. So I'll write it again down here. So tangential acceleration is equal to r prime of t dotted with r double prime of t divided with r prime of t magnitude. And we've already computed all these numbers. So what we're going to do now is we're going to just go ahead and plug these values in. So our r prime of t dotted with r double prime of t, so tangential acceleration is equal to this thing right here. So 120,000 t to the fifth plus 18t cubed plus 256t. And we are going to divide this by our magnitude of velocity. So our r prime t magnitude was t times 4000t to the fourth plus 9t squared plus 256. And all this was inside a square root. So now, what's the next step? The next step before we finish to compute this would be to, what we're going to do now is we're going to plug in time. So t was equal to 1 as given to us at the beginning of the problem. We were given, with this bit of information, we were given. So we're asked to find the tangential acceleration at a time of t equals 1. So now we simply, everywhere we see t, we're just going to go ahead and plug in 1. So at at a time of t equals 1 is equal to this number times 1 to the 5th power plus 18 times 1 to the 3rd power plus 256 times 1 divided by 1, our square root, 40,000, 1 to the 4th power plus 9, 1 to the 2nd power plus 256. And when we plug this into our calculator, we get some crazy answer, but let's see. At time of t equals 1, 18 plus 2, 18 plus 56 is 74, 274 plus divided by 9 is 265. So you can either leave your answer like this, or you can use your calculator and plug it into your calculator. And if you do that, we get an answer of 599. So either one of these two answers will be acceptable. You can either present your answer like this, or you can compute it in your calculator and get 599 point some decimal. But anyways, that's how you compute tangential component of acceleration. So quickly in retrospect, what did we do? So we look at the formula and we do, the first thing we do is we are given a position vector. So take the first and second derivative to, I don't know why I put dot product here. Scratch that, you don't need that. Okay, so first and second derivative. So we do that, then we find the magnitude of r prime of t. And we do that, a lot of computation. And when we did the magnitude, we did all this arithmetic, factored the t's out properly. Yeah, we factored out the t's. Then we split up the square roots, a bunch of arithmetic. This was our r prime of t. We came out to this answer right here. Then the next step we did was we found r prime dotted with our double prime. So we just got these two vectors and dotted them with each other. We multiplied element-wise multiplication, and we got these values. And then the next step is we just plugged it into the formula. Right there, all we did was just plug and chug our dot product divided by our magnitude. And then we plug in the time of t equals 1. So we plug in 1 everywhere we see t. And then we came out to these answers. These answers are equal to each other. But this is radicalized. This is when you compute it in your calculator. Thank you for watching. I hope that was helpful.